All right, good morning. I have 10 o'clock. Let's get started, please. I'm Bill Griffith with Rexel. I am the industrial sales manager here, and my role today is to make a couple of introductions and then get out of the way and let the experts spend time sharing information with you. Throughout the course of the presentation, if you have questions, feel free to use the chat section in Teams, and we'll read through those and make sure that we get answers to all of your questions. So today, I'm very pleased to introduce a couple of guests. We have Mike Riethmeyer, who's the territory business leader from Rockwell Automation for their automation and software solutions offerings. Today, Mike is joining us to talk about new process controllers. Also joining us is Jeff Canizo. Jeff is with Trinova. He's a sales engineer, and today he will be talking about E&H instrumentation and working, I'll say seamlessly, or working with easy integration to the Rockwell process offering. And also with us is Steve Fry, who probably everyone knows. Steve is the product manager from Rexel for our process control solutions. And I believe not comments to get us started.
Okay. Thanks, Bill. I just got a brief message I'm going to deliver to everybody. This is Steve Fry. Before we get Jeff and Mike engaged in this event, again, as Bill pointed out, thanks for spending the time with us here this morning. It is important you to know that we are recording this event, so just so you know. Just a quick agenda, the introduction, we've already done that. The Rexel USA website, I'll do that in a moment. Jeff will be doing the collaboration and smart instrumentation talk. And then Mike will be doing a live demo with the Rockwell Automation new process controller. And then as Bill pointed out at the end, we'll address questions that you may have via the chat window. The Rexel, just to mention, especially in these times where we're all working remotely, we do have the Rexel USA app. If you haven't got an account, it's easy to do. If you need some help in getting it set up, either your account manager or someone like me or an inside guy can help get you set up on it if you're not already set up on it. Why would I do it? I can create bill of materials. It's easier to place orders. I can find my net pricing if I'm a customer. And probably the thing that I find most frequently when people use this application is they can find out what we have here locally in stock, either in Buffalo or just a little bit further down the road in Jamestown. So you can tell very quickly just how quickly you might be able to get the product many times from our warehouse. And if that's the case, it'll show up in stock. And with that, I'm going to turn it over to Jeff Canizo, who will be doing the E&H portion.
All right. Let me know when that pops up, Steve. Can you see that?
It looks like you're loading. Yep, there you go.
Okay. All right. Hello, everybody. And thanks to Steve and Rexel and Bill for giving me a few minutes just to say hello and tell you a little bit about why somebody else might be stealing some of Rexel and Rockwell's time. I am the Endress+Hauser rep locally, and we have an alliance, a strategic alliance partnership, Endress+Hauser does, with Rockwell Automation. So what I wanted to do is just take a couple of brief minutes and tell you what that means and why it might be important to you. So just quickly, Endress+Hauser is a global manufacturer of process instrumentation. We're headquartered in Rhinox, Switzerland, and our U.S. headquarters, as many of you know, is in Greenwood, Indiana, which is the Indianapolis area. Founded in 1953 by George Endress and Logix Designer. And the company today is still family owned. It is still a privately held company. You can see the 2018 revenue is 2.6, and the 19 numbers were just released the other day. And they are just under 2.9 billion US dollars. So a growth in 2019 of about 10%, which is good for this market. So what is a strategic alliance? Is there's different levels of partnerships with Rockwell, and the alliance partnership is a top tier partner, and we're not really here to just sell product through the Rockwell distribution. We are still representatives, but basically the alliance is to bring together two corporations that kind of can build off each other and use the capabilities of one another to broaden their offerings to the market. And really that involves process solution capabilities. Endress+Hauser is a manufacturer primarily of process instrumentation, and Rockwell does not really manufacture process instrumentation. So the two of us together can offer a system solution, and that's really where the alliance partnership is driven. A lot of it has to do with system integration and the benefits that we bring to you by working together before you actually purchase the system. And it's basically done to deliver more value to the customer. So if you break it down, we each manufacture products. Okay, Endress+Hauser makes instrumentation, and Rockwell makes all types of products, from drives to controls, et cetera, et cetera. But they do not make instrumentation, and that's where Endress+Hauser kind of fits in. Our partnership revolves a lot around networking, Ethernet IP, HART, Profibus, Field Bus, and really defining how the systems, how the products can work together, so that then when they hit the field, it's much easier for you to integrate. We do offer actually packaged solutions together. Many of you may not know about those, but we work on them, especially around Western New York and in upstate New York all the time. One of the biggest ones is overfill protection, where Endress+Hauser offers a packaged solution that combines our instrumentation for tank farms with the Rockwell control systems and graphics. And we call that overspill protection. And we combine that with inventory management and other asset management. We do system platforms where our instrumentation is communicating directly with the Rockwell systems. And then of course we do, much larger engineered solutions. So our primary focus area is kind of in the middle between what we would call manufacturing and process, and it really lends itself. It builds from the middle into the process industry. So food and beverage, where we see a lot of Endress+Hauser. It's by far our strongest market, and we also see a lot of Rockwell automation. Life sciences, any of the pharmaceutical businesses, and water and wastewater treatment. And those particular industries really move from manufacturing piece parts and robotics into, more process. And then, of course, that lends itself right to full-blown process industries where you need, high-end control systems. Some of the key benefits. A lot of the integration is all pre-engineered, pre-tested. We work together with Rockwell well ahead of the release of instruments with things like Ethernet IP. So it by working together gives us a much faster time to market. It really decreases the risk to the customer. Allows for seamless integration. It basically allows you to plug in and build a digital enterprise very quickly. Gives you a lot of time savings on integration and cost savings because of other reduced time spent in the field getting things started up. So all the things that you need, faceplates, add-on profiles, these things are all built and tested prior to the instruments being released. So today, on the Ethernet IP platform, we're still limited primarily to the 4-wire devices, the powered devices. And these in the Endress+Hauser side include magnetic flow meters, Coriolis flow meters. We're just releasing the thermal mass meter with Ethernet IP. On the analysis side, our liquid analyzers. The Liquiline product line is Ethernet IP capable, and that allows you to plug in a whole variety of analytical sensors. And then we have some other devices that are currently today Ethernet IP capable, and that's some digital recorders and things like that. E&H is also pretty strong into IO Link, and that's just a platform that we see with some of our I don't want to say lower costs, but simplified instrumentation. Some people are looking to IO Link to digitize their automation side. One other thing we do together is what's called a process training unit, and these exist throughout the country. Right now, we do not have one in upstate New York, but the plan is to have one in the next year and a half or so. We'll be in the Albany area. And these are basically training centers that contain just about every instrument that Endress+Hauser manufactures, and everything is live, and the whole system is controlled by a Rockwell PlantPAX. So people across the country have used these not only for instrumentation training, but also for Rockwell training, where you can come in and do things live and see how what you've made, the changes you've made on the control system are affected right there in the process. So these are all live training units. Everything contains water, but you're able to manipulate, break down instruments, and do the same thing with the control system. So these are located throughout the country. Again, right now, the closest one is probably Philadelphia, but the hometown in Greenwood, Indiana is an easy jump on a plane. And that's actually the biggest one right now. And then eventually we'll have the one in Albany, New York for upstate New York and New England. And that's it. You can, most of you probably know how to get a hold of me, but if you don't, I'm right here in town. And there's my number and my email. So thanks. If there's any questions, you can shoot me a note or give me a call. Thanks, Steve. I'm going to hit this stop.
Does that mean I'm up next?
Mike, I think it's you. Yes, sir.
All right. I am Mike Riethmeyer again, a technical representative from Rockwell Automation in Rochester, New York. And I think I've spoken in front of the team here in times past. would like to go through really several things. One would be some new capabilities around HART-based devices, of which there are a boatload in the world, both manufactured by Endress+Hauser and others. And we've been adding better integration into that legacy, if you will, installed base of HART-based instrumentation. And I also wanted to give a preview of some new capabilities coming up this, well, let's say late summer, early fall, with our PlantPAX 5.0 system release that's coming out in conjunction with Studio 5000 version 33. And in both cases, I'm going to primarily do that as a demo where I've got a access via the cloud to a pre-release version of our PlantPAX 5.0 system running in our headquarters in Milwaukee. And they've made the equipment available to us, again, on a pre-release basis. It's actually very similar to a lab that was made available at Automation Fair, or more specifically, our Process Solution User Group meeting the couple days before Automation Fair back last November. So it's actually a very early pre-release of the software and firmware and hardware, but I thought it would give kind of an indication both of some of the HART integration that we're talking about here and some of the new features in the PlantPAX 5.0 system. Maybe to quickly ground ourselves, if you guys will indulge me, I will share my desktop here and briefly show you a few slides, I guess. Hopefully this will come up shortly. Is anybody seeing my slide?
We see on Mike.
Okay. Interestingly, I don't see it on my second computer here, but that's all right. So what I wanted to talk about in particular, we've got a capability called highly integrated HART, and the first release of this capability is in a new platform of I/O called Flex 5000, very similar to the older Flex I/O that we've had for years and years, what we called our 1794 Flex I/O. A few years ago, in conjunction with our new 5580 control Logix and 5380 compact Logix processors, we came out with a series of optimized I/O for those newer controllers called Flex 5000. It's the 5094 catalog number system, and has a lot of high performance capabilities for both standard and discrete process control analog kind of instrument I/O devices, and even safety, discrete safety kinds of applications for I don't know, if somebody goes through a light curtain and you want to be able to shut off safely the variable frequency drives in that part of the system. Those kinds of capabilities are all built in. And it's got a lot of flexibility about how you wire the thing up with what kinds of network architectures, from simplex all the way up through parallel redundant paths of Ethernet. So it should be able to fill just about anybody's needs for a highly available, super high throughput, very capable I/O platform. And again, handles digital, analog, as well as safety modules. The ones shown on the right here with the H at the end, the IF8IH and the OF8IH, are HART-based analog modules. You don't have to use the HART capabilities, but we'll be talking a bit about what comes from doing so. And if we look specifically at them, that these modules have a new capability that we're calling HIH, or highly integrated HART. Again, recognizing that in new applications, wherever possible, I'd love to see you folks taking advantage of Endress+Hauser's Ethernet IP-based instrumentation. It's incredibly fast, high throughput, very flexible, lots of information made available with very little work to do. But again, recognizing that there's a lot of applications that use 4 to 20 milliamp devices, and that most of those 4 to 20 milliamp devices probably have HART built in, for at least for initial commissioning, and maybe that HART capability is being ignored after the fact. Here we can be hooking up the analog modules, 4 to 20 milliamp analog, going to those devices, but also take advantage of the HART digital communications that exist on many of those existing field instruments. And some of what you'll see then, as shown on the right, is that now we have the ability in the I/O tree of our editing software for the processors, Studio 5000, to be able to drill down in to the actual channels of HART instruments and to be able to see the devices that exist on those networks and to get a little more information out of them. This is our first release, so it's not complete, but it's got some pretty neat capabilities already in release 1. An example of this is that if you look in the I/O tree of the processor, that now you'll be able to see as you drill down into a Flex I/O module and into a particular point that you're going to be getting not just the standard data, but that I'm also going to be able to drill down a little deeper and see information about the channels, the alarms that are associated with them, additional information about those HART devices. So again, as shown here, we're able to drill down in our I/O tree, see not just the I/O channels and cards, but also the devices that sit on HART that are connected to those channels, and to be able to configure them in many cases in ways that are powerful and be able to see their diagnostics and extended information. So that's the piece about highly integrated HART. And then I also have just a few slides on the new PlantPAX 5.0 system that I'm going to be demonstrating here in a moment. And this is a huge investment from Rockwell in really extending what we've been doing for the last 10 years with PlantPAX, building a characterized high-performance process control system using relatively standard pieces and parts in the Rockwell portfolio, our control logics and compact logics processors, our I/O devices, our FactoryTalk View ME and SE HMIs, and moving that forward now into an even more tightly integrated system. We have our process object library we've had for the last 10 years of add-on instructions in the controller and corresponding faceplates and graphics in the HMI that provide a very powerful user-rich environment that helps comply with industry standards like, ISA 18.2 for alarm management, ISA 101 for high performance graphics, where we're not overloading the operator with information that they don't need to see. But here we've taken this now even a step further and baked a lot of those kinds of capabilities directly into the controller. We've come up with some new hardware. We're actually showing it here. A compact Logix and a control Logix that's in a dark charcoal color, which indicates that these are process variations of our 5580 and 5380 processors with a P at the end of the catalog and a string that indicates that they're actual PlantPAX controllers. You've always used standard PlantPAX or standard control Logix and compact Logix in the past with PlantPAX. Now, if you like, you'll be able to buy specific processors with some even greater functionality should you choose to use them. You can still use standard control Logix and compact Logix, but you'll see some of the new capabilities when you move forward with this new set of processors, new variants of the processors that are that much more tightly integrated. So some of the things we're trying to do with 5.0 are to make systems lower cost with reduced footprint, more consistency on how they get delivered to people, less opportunity for variation. It helps with the characterization and guaranteed performance. We want to make it as easy as possible to build these systems and to make sure that they're as secure and maintainable as possible. So as I mentioned, in the compact Logix family and in the control Logix family, we've just come up with some new variants that have process as their main focus. And so they're dark charcoal in color, and we'll have a P at the end of their catalog string. But as we look at them, they're going to come in a couple of compact Logix sizes of memory and 4 sizes of control Logix. They've got some capabilities like guardrails, which may be a term you haven't heard before. And the idea there is that there's built into the firmware diagnostic capabilities to be able to warn you if you haven't configured it following the rules of PlantPAX to provide the guaranteed performance. If, for example, if we said that you're allowed to have, I don't know what the number is going to end up being, but let's say it's 125 control loops per processor, and you put in 126, that it would warn you that you may have poor performance or you're falling outside the bounds of normal operation by having put in slightly higher amount of loops than what the controller is nominally designed to handle. So those kinds of things are built in. Another huge step is that if you've used PlantPAX, we've had, as I mentioned before, built-in add-on instructions in our process object library. They start with a P underscore analog input, P underscore analog output, P underscore PID loops, that sort of stuff. Now these are baked into the controller firmware for these new processors as native instructions, and we'll see that in the demo in a moment. Should make your work a lot easier. You don't have to be bringing in these libraries from us. It's built into the firmware of the new processors. Similarly, a lot of the faceplates where you would do configuration and maintenance inside of our HMI in a PlantPAX system in the past is now baked into these Studio 5000 instructions. So you can still get at them from the HMI, but you'll also be able to get at them very easily inside of Studio 5000. So hopefully that makes some sense. And again, we'll see that in the demo. Another huge part of this is we've been adding capability to our process control, our compact Logix and control Logix processors in the 5380 and 5580 families to be able to essentially check a box in the tag browser in the controllers, to be able to say that a tag is not just a tag, but it's also a factory talk alarm and event. And you can configure what values would cause it to trip and what kinds of events would happen when it goes into alarm, and what part of the system, what area of your facility's alarm system is it associated with. All of that now is built into these instructions in the controller and can easily be turned on and off, either manually or programmatically. So you don't have extra steps to do to configure alarms for the system other than just initially ticking the box that you want them and specifying perhaps what's the high and high values and low values. Our networking has gotten more baked as well in terms of our system selection tools, Integrated Architecture Builder. We've improved, as I mentioned, with HART. When I talked about the HART-based Flex 5000 modules, that we also have networking options, including parallel Ethernet segments that allow high levels of failover and capability to keep the system up and running. And we've added abilities to more easily flash the products to a consistent level that you've designed towards, and to make sure that you're aware when there might be anomalies in those firmware releases. And that falls into maybe the last piece that I think is really critical, is that to keep these control systems viable in this new interconnected world, where we're seeing so many hackers now targeting control systems, that there's an international standard. It used to be the ISA 99. It's now called the IEC 62443. But Rockwell, as part of the 5.0 PlantPAX release, is putting together a standard architecture that is cyber secured, that is being TÜV certified to these set of standards, that you'll be able to build your control systems and know that if you follow the rules that we set up in this white paper that's shown here, that is what is being TÜV certified as cyber secure, you'll be able to go and design systems that are very robust and maintainable over time, and should minimize the risk of people getting in and bad actors breaking things for you. So that's what I wanted to show regarding these products. Now I'd love to actually dive in and show you a demo, that pre-release demo of this hardware and software that we're talking about. Fair enough. Any questions at the moment, Steve? Anything in chat I need to go through?
Nothing that I see yet, Mike.
Okay. So what I'm going to do here, can you see my Windows desktop of my demo?
I can.
Okay. So I'm going to go full screen. This again is a demo that's running in Milwaukee, and it's using firmware that we showed people back at Automation Fair. The actual release of this stuff, version 33 of Studio 5000, should be coming out later this summer in the July-August timeframe, and the actual new process controllers, PlantPAX 5.0, should be coming out a little later than that, perhaps September, give or take a month. But in any case, so probably we're a little farther along in our development, but I think it's still interesting to show how some of this stuff works. Some of the things that we're going to talk about are going to be, again, kind of baking in what we've had for 10 years as add-on instructions into the actual firmware as native instructions of the processor. We're going to be talking and showing a little bit about the highly integrated HART. We're also going to be showing some usability tools that help us organize equipment into groups in ways that are much more powerful and easier to use than what we've had in the past. So the first thing I'm going to do is open up Studio 5000. And So here we've got, hopefully this looks familiar if you've used our Logix editing tools, Studio 5000 in the past. And we've got a sample program that's already running here. What I'd like to show is that if I were to come down into one of the tasks that's in this control system already, in this case, the normal task runs at a 250 millisecond rate, that we could come down in and add into this particular program that we've pre-created called Vessel 01. Let's bring in some code to actually interact with a vessel. And this hopefully won't be new to you if you've used PlantPAX in the past or seen me demo some of it, but we've got, as mentioned, a whole library. In the past, it was add-on instructions and faceplates for HMI, and we grouped them together into things we called process strategies. So you didn't have to wire all this stuff up. You could just bring in a whole control strategy set of code for an analog input with a PID loop, for example, and controlling an analog output. Similarly, what we're going to do here is import in a chunk of configured code that will be going along with and delivered with the PlantPAX 5.0 this summer. Here's a version where we purposely left a little chunk of it out so that I can show you some of what's in there. So this is a control strategy somebody already created for interfacing with an analog input and analog output module. And in this case, I'm just going to go ahead and accept it. You could change the name of this particular device instrument if you'd like, but we're going to call this loop the FY0921 loop. And as it imports in, you'll see now that we've got a subroutine here in our IO tree. If I double click on that and open it, you'll notice that it's got already, as part of this, a PID loop for controlling this function. We've got an output, and this is one of the new PlantPAX instructions, a process analog fan out that's going to be going to various analog output devices. And then there's something missing in the middle here, which would be my analog input device. So what we're going to go ahead and do is go up to my instruction palette here at the top. And just like where we've always had groups of native instructions, and you could have gone with PlantPAX in the past, imported in a whole bunch of add-on instructions and seen those add-on instructions here. What we're going to do is navigate through to a new palette that's up here that's called PlantPAX. And these are instructions that are now natively baked into the controller. No need to import these. They're part of the firmware used with those new gray process controllers. And if I brought in now a process analog input block, drag it down onto my page, I'll be able to start to wire this thing up. And there's various things that I could interconnect here. Perhaps the output of my analog input block. This is going to connect to maybe one of Jeff's analog instruments that he was talking about earlier. If I take the value that we're reading out of that analog input and bring it into my PID loop as my process variable, the measured variable we're going to try to control. And I could similarly connect an error signal, if there was one, to my process variable fault here. I've now got this chunk of code wired up. I could also come and wire up some things on the left side, the inputs to this instruction, which would be coming from the analog input device itself. One of the things that this particular instruction doesn't have showing, but we would like for this control strategy, is some status information, error information. So what I'm going to do is come into this ellipses button at the top, and brings up the standard dialog box under parameters over here. You probably have seen this before if you've used our function block library or our add-on instructions, but I don't know, about halfway down, there's a block here for status PV bad. So I would like to know if the process variable is actually not useful, if it's broken in some way, before I go and start trying to act upon it in my PV loop. So what I've done here is to click on a visibility button to make that item available. I'm going to click OK. And so now there should be this PV uncertain term here that I could go and wire up to my already configured values here on the left-hand side. So I've got a process variable uncertain, and I've got my actual channel data, the value that's being read out of that analog instrument. So Maybe to be a little more clear, this stuff on the left is coming from perhaps a point IO module, or in this case, the Flex 5000 IO that we were talking about. So I actually connected, hopefully via HART, to one of those kinds of process instruments that Jeff was talking about, connected on up with my analog process input and my value to tell me if it's good data quality or not. I have the ability to come and now with this process analog input block to scale the data, to handle alarms and things like that. So normally, again, as I mentioned, if I were coming and creating code, what we would like to have you do is not have to wire all this stuff up, that you'd come to import a routine and you'd pick a complete one like what is shown here. And then everything comes along for the ride and you just have to rename it as appropriate and away you go. But wanted to show you a little bit that when we come up with the release this fall with these native instructions, that all of this code will be fully baked in and wired up for you and configured properly as part of that control strategy, process strategy library that we make available. All right, so the next thing that I would like to do is to rename this object, because if you notice here that when we brought in this control strategy, they came renamed with the instrument names that we want to use. In this case, PAI_01 is not a really useful name. So what I would normally do is come in here and rename this thing to be my flow indicator. And in this case, it's the 0921 flow indicator. And it probably would make some sense to type in here that this is the vessel 01 flow meter, and I could apply those changes and close. And now we should see that this particular analog input scaling block has the name that matches the instrument in hopefully our piping and instrument diagrams. Okay. So what do we want to do next? Let's take another look at, let's say we've added in this analog input scaling block, if you will, and handling block. Again, with this process instruction with these ellipses we have here, we can bring up a dialog box. We'd gone before to the parameters tab and added some more objects, buttons on the left, or nodes to wire up to on the left and right. But if you notice, there's other tabs on here, and these should match up very nicely with what we used to have to see inside of our HMI, where we have a SAMA diagram, an industry standard view of the flow of data from the input from our instrument through the scaling, through virtualization, where, for example, if you want to simulate the input because we're testing before we've commissioned it, or if I have a bad instrument and I need to temporarily manually type in values that I'm collecting from the machine so that I can continue to limp along, that I could use this substitution value. There's built-in filtering for the input to make it nice and smooth. And with appropriate security, you can modify these values from right here inside Studio 5000. You can still do it in the faceplates inside of the HMI, but you can do it here as well. There's another tab for the failure flow if you want to deal with things that are out of range. And again, another tab here on advanced to handle what do we do when certain things aren't quite in normal operating status. There's HMI information if you want to pass along back to the control system. What part of the machine is this in from a security standpoint, so that operators, only the correct operators for that portion of the plant have access to be able to modify these things. Again, factory talk alarms and events are built in, so you can configure, tick the box to say whether I'm going to have alarms for high and high and low status, rate of change alarms, all that sort of stuff. So that's kind of neat. Again, built into the controller, very little you have to do now to set up a full functioning system. Next, well, yeah, let me go back in there. A couple more things that are probably worth noting that I don't want to gloss over. On the HMI tab, if I were to come in here, you could certainly tell this thing what particular library it is participating with. So maybe for the library of HMI objects that are going to pop up, which set of those do we want to use? Which particular type of instruction is this, so that the HMI knows what HMI object to pop up? You could give it a label and say, all right, this is a flow meter. You could tell it that it's in area 01 of the plant, and you could put in what are the engineering units, the scaling that you're going to be displaying the numbers in. So on the HMI, that it will come up and show you that I've got cubic meters per hour of flow with raw units of milliamps that we're reading out of this 4 to 20 milliamp instrument. So you could click on that sort of thing. Another thing that's kind of interesting is if I go to the alarms area, again, I could go and configure that I want to have a high alarm, specify what the value is that would cause it to go into alarm. Maybe maybe the limit is going to be, I don't know, 2,800 cubic meters per hour of flow would be a high alarm. There's also a button here with ellipses where I can go into more detail, and you'd be able to see here that that I can go and type in a message for what's the particular type of alarm. I can modify what the value is. I can click this button to say that I want to actually use this particular alarm in my control system. There's also areas for class and alarm group that are going to be indicating, again, which part of the machine or our facility is this alarm associated with. So if I'm filtering my operator interface alarms to a particular operator so that they only are being bothered by the alarms that are appropriate to them, that shows up here. And I could manually type those in, or if I click OK, I could come down here and there's an ability to set some of this stuff for all the alarms associated with this particular instruction. If I were to do that, I might put in that this is what type of alarm this is would be analog input. So I could do some filtering in my alarm banner later on in my HMI to look for any alarms related to analog inputs. And I could also specify that this is related to vessel 01. So now any of the alarms that are associated with this analog input are going to be filterable and sortable based on coming from, and I'm looking again at this particular one that had been empty before, but now it shows that all these high, low are going to be associated with vessel 01. So if I want to filter my operator's alarm banner to just vessel 01, these would show up in there. That makes sense so far? All right, moving on. What I'd like to do is to move over and actually show this thing online. So let's go online with my controller. Again, there's one of these pre-release ControlLogix process controllers, PlantPAX process controllers in Milwaukee that we're connecting to. And we just successfully went online. The processor is in run mode. Okay, a few things to note here. One of them is that while this processor is in Milwaukee and we're online with it, the actual I/O that it's configured for is not set up out there. So it's got some yellow warning symbols here to indicate that. But I think it's still useful to show that stuff is in the I/O tree, that our code is associated with it. And when you're able to commission those I/O devices, really bring them online, connect them to the network, they would start to populate and flow through properly, working the way that we want. So let's flip over briefly to the operator interface. And here's just a very simple process graphic that someone has created that shows that I've got my vessel 01 and we've got a flow meter that's set up here. This object here, this symbol, I'm going to call it a widget, is something that you may be familiar with from our process object library, that we've had these for a long time. They could have little thumbnail trends. They could have kind of a gauge indication, or it could just be numeric as shown here. But if I go and click on here, I'll pop up a faceplate that's got more information. Again, this should look similar to what we've had before. It's based on, while this is 5.0, it's based on what we've done from a look and feel standpoint in our existing 4.6 library of graphics. And there's a home page of this pop-up. And again, with a security model that's robust, that handles what area of the facility operators are allowed to interact, or maintenance or engineers, you can come in here and see that right now we've got a value of 50 cubic meters per hour, which is actually way down here toward the bottom of the scale. And you'll notice both here on the main process graphic, this little arrow down in black and another one here indicating that we're in an error condition, that we're low. And that means we're below the configured low and low alarms for that object. You can actually see that if we were to come here to the next tab and with this little wrench, from a maintenance standpoint, you can see what we're configured for the levels to be. If we're below 150 cubic meters per hour, that we're going to be in this range that would be low, and at the moment we're at 50 or 50 over here. So that's why we're getting that indication, that breadcrumb we call it, that we're this black arrow, that we're in a low state. And with appropriate security, you could modify that from the HMI. As shown before, we can actually do that from inside Studio 5000 very easily too, with a similar set of objects. If you wanted, you could kind of trend this thing here. Let's say I wanted to see a trend of the process variable, the analog value out of the instrument. And we could see that showing here that we're at 50. It should be a nice straight line. There's also some diagnostics where I can look and see here that if we're in a simulation mode and if there's any alarms that are active. Here's an alarm nobody's bothered to configure with a name yet, so it just shows with a bunch of question marks. All right. A couple more things to show. If you haven't seen this before, the maintenance tab, this wrench tab, has multiple sub pages, 1, 2, and 3 here. So the first one is showing me where I can set my high and low values, where I can specify what's going to be an out of range value, that I can do some clamping, that sort of thing. There's also an advanced tab here where I can start to come in and modify, again, multiple sets of things related to whether there's a delay before I go into an alarm state, that sort of thing, where I can specify the scaling for the object, if it's linear or some kind of exponential kind of scaling. If I'm going to allow people to substitute a value, to simulate a value when we are when we haven't got our actual instrument in place, but we want to do code testing, or if the device is out of service and we need to continue to run in spite of that. So again, multiple sets of things that with appropriate security, you'd be able to come in and modify here. There's also an ability to change what the text is going to be on this object. And this is all standard PlantPAX stuff that we've had for a long time. Now let's flip back, if we will, briefly to the editing tool, Studio 5000. And as I was mentioning, in the IO tree with this highly integrated HART stuff, that we've got here a Ethernet card in the same rack with the controller. Out over the network, we should have one of these new Flex 5000 Ethernet adapters, and on that rail of Flex 5000 would be a analog input module, the IF8IH HART module, which now has this highly integrated HART capability. And you'll see that channel 0 of that device is connected to an Endress+Hauser ProMag 400 flow meter. And I should be able to click on that device and bring up the wizard, if you will, for configuring that thing. But at the moment, I would rather take a look at this from inside of, well, I guess it's here. We can take a quick look. You'll be able to see that we've got this device, what firmware level is in it. We're connected to it at some kind of rate, in this case, 500 milliseconds, and some information about it. Now it's reporting errors because it's not actually online right now, but we'd be able to see, for example, here, the process variable that we're reading, and some more information that comes from HART digitally than just the analog 4 to 20 milliamp signal coming from that legacy instrument you might have out there. Let's flip back to the HMI. And in here, if I come back to, well, one more thing, let me quickly show you. On the substitute values I mentioned, I could simulate if the device is out of service, or in this case where it's not actually here, I could come in and simulate that somebody actually had a real instrument and put in maybe that, I don't know, it's reading 1,000 cubic meters per hour. And so now I can see my trend window starting to move, and I come out of the alarm state, and that I could go back down again. There's another breadcrumb, this black triangle, to show that I'm in a substituted value. So the operator should be able to see that things aren't quite normal, but it's not the alarm situation anymore. And I could go and substitute back a value of 50 if we'd like we had before. I could turn off the substitution and just be trying to read the actual instrument again, that sort of thing. But let's go back to this advanced properties. And on this window here for the HMI configuration, let's enable navigation to, I want to cascade through to be able to show some additional information that you don't have to program, you don't have to configure in the HMI other than, or create in the HMI other than just to configure this. What this little checkbox does is now create a new tab on here that allows me, knowing that this is a HART device, to be able to pop up a HART faceplate. And the HART faceplate gives us some additional information that I think is going to be useful. So if we take a peek here, it's showing me the primary value, which in this case, it's a mass flow meter. So it's showing me what that value of mass flow is. It's showing me a secondary and a tertiary and a fourth value that are standard HART functions. In this case, being able to read the temperature, not just the mass across the 4 to 20 milliamp. I'm able to get these digitally. So those kinds of things are kind of neat. There's, again, maintenance available if I want to virtualize. I can take this instrument out of service and not read the actual value of what it's connected to, but to simulate that. There's an ability to come and, again, with appropriate security, to specify if it actually is able to read a primary, a secondary, a third, and a fourth value, and to do some scaling if you like, or to specify that most of the information is going to actually be coming from the instrument itself. However you've configured the instrument is going to cascade back through to the PLC and to the HMI for what the units are, those kinds of things. So again, a lot of functionality coming along for the ride by leveraging HART and being built into so many devices that are out there already. Okay, so what else would we want to show? The last basic thing, I guess, that I'd want to show people is something called ownership and arbitration. So let's really briefly take a quick peek back over at the control system PLC program.
Hey, Mike.
Yes.
We're coming up on 11, and I'd like you to leave, maybe 5 or so minutes for some questions at the end. There's at least one in the chat window.
Okay. Well, and you can feel free to read that to me now if you'd like.
All right. Well, let's see here. Question that came up. Actually, there's a couple now. Okay. In the HART, or excuse me, in the HMI, can the alarm banner filter to more than one group?
Yes. Yep, we've got flexibility to set up groups and to look at multiple groups as part of the banner. So that flexibility is there.
Okay, and then we got another one here. Is the HART module only available within the Flex family of controllers?
We have HART modules for a whole bunch of different families. This new highly integrated feature where the actual instrument shows up in the IO tree is what we call highly integrated HART. And at the moment, that's only available with the 5380, 5580 processors and the 5094 Flex 5000 IO with these HART modules that are available for it. I expect we'll be adding more capabilities to other platforms down the road, but at the moment, that's where we've got that really tight integration. But we still could do HART and get a lot of this kind of stuff in the past with the older systems. Let me quickly pop up here. If I look at this particular control strategy that was created by somebody else, there's an object down here at the bottom called bus object. And this is an array of objects, a grouping of control elements that are going to be all grouped together into one unit that we can start to manage as a whole unit instead of a collection of pieces and parts. And to kind of finish up this exercise and demo, I'd like to quickly show what that means. So if I were to come over to this particular process diagram, you can see there's multiple pieces of equipment, a TK100 train, a TK200 train, and there's now this concept of organization and arbitration. If I look in here, you'll see that I've got a tank farm, and I've got the ability to expand this into the TK100 and TK200 views of these particular instruments. So in this case, I got my flow meters, my pump, my output device, if you will. And if we wanted to add another device to here, we can come to edit mode and be able to now come to a container and to click on here, in this case, the TK200, and to add a child. Maybe I want to add that new device we added earlier, or maybe another one like, let me just close out of here. There's one here with a question mark now that was just added, and I could come in here and I could rename this thing, and I could specify what he's associated with, and be able to use it effectively that way. So in any case, my point here, and some of what you'll be able to see, maybe you could see it more effectively here, is that now I've got an ability from an alarming standpoint to be able to acknowledge all the alarms for a grouping of equipment, not just an individual device like a valve or a pump, but I could acknowledge the alarms for all of those. I'd have the ability to change the mode for all of these from being in program mode to being in operator mode. In the past, I've had to go into each one of these objects and change it to operator mode if the PLC had been controlling it, and I now wanted the operator to take manual control. So those kinds of capabilities now exist in this ownership and arbitration mode, and you can specify whether the PLC's program has higher priority than the operator or vice versa, so that maybe the operator shouldn't be able to take control when the program is trying to use it. But those kinds of capabilities exist. And that's basically it. So those are the three things I wanted to show inside of PlantPAX 5.0. Are there any additional questions or comments people have about the system, the capabilities, what we're trying to do, those kinds of things?
Yeah, you could either still chat them in, or you could raise your hand at this point if you want to just address it directly.
Feel free to unmute yourself if you want to talk.
Yeah, at this point, unmute. I think most of you are muted for the bulk of the session.
Well, I either put them to sleep or we completely thoroughly answered everything people needed to know.
We didn't lose anybody, Mike, so you did good. Thank you.
All right.
Yeah, good job. Great job.
Yeah, go ahead.
Okay, well, I guess if there are no more questions, and I don't see any more, we'll just call it a session. Again, thanks for spending an hour with us. I hope you got you got something out of it. I think there is a survey, so please take a few minutes to complete that if you would, to help us do better in the future.
Yeah, thanks so much, everybody.
Thanks, everyone.